The core product assembly includes the piston connecting rod and Wispin key engine parts designed to handle extreme temperature, pressure, and state. The piston is made from aluminum alloy using casting offering lightweight, good heat dissipation, and wear resistance. The connecting rod uses microalloy forged steel to rolling and forging for high strength and durability under heavy load. The Wispin is made from case hardening steel using wire drawing, providing a tough core with a hardened surface for excellent wear resistance. Together, these materials and process balance performance, cost, and sustainability to create strong and reliable engine assembly. Material selection: First, piston made from aluminum alloy. Thermal: It has the exact thermal conductivity allowing efficient heat dissipation from combustion. Weight: Very low density reduces the lubricating mass, improving engine response and efficiency. Wear: Very high wear resistance, extending the piston lifespan. Manufacturability is highly castable, meaning it can be formed into complex piston shape during casting. Connection rod: Made from microalloy forged steel. Strength: It offers very high tensile and fatigue strength, crucial for handling and repeated stresses during engine operation. Forking the process allows the crane structure improve durability and mechanical performance. Cost and machineability: These materials balances cast efficiency with good machineability after forking, making it practical for mass production. Wrist pin: Finally, the wrist pin is made from case hardening steel, which provides combustion toughness and wear resistance. The hardened surface resists friction and wear. The pin meets the piston and connecting rod. Core strength: The low carbon core maintains toughness to absorb impact loads. The wire drawing process allows the steel to be precisely shaped before final grinding and hardening treatment. So this slide shows the design layout of the piston assembly. So as you can see, the system includes three main parts. So start with the piston, connecting rod, and wrist pin. So the piston is the upper component that moves up and down inside the engine cylinder. The connecting rod links the piston to the crankshaft, transmitting motion and force. The wrist pin, also known as the gudgeon pin, acts as the pivot point between the piston and the connecting rod, allowing free rotating during operation. The design is divided into upper and lower connecting rod sections. It requires different manufacturing and material properties. The design was chosen because it balances strength, weight, and motion efficiency. Actually, the assembly performs reliably under high stress and temperature. So, understanding the design is essential because every manufacturing process we choose later casting, forging, rolling, and wire drawing directly support the function and structure needed for each these components. So next slide you will see the video of assembly and reassembly of the piston and the connecting rod and wrist pin. So the piston is manufactured through casting routes, especially squeeze casting or gravity die casting, using an aluminum silicon alloy. The process starts with material preparation, followed by casting, deflashing, and initial inspection. Then CNC machining is performed for precision followed by surface treatment, typically anodizing or coating, to enhance wear resistance. Finally, quality inspection ensure accuracy before the piston is sent for assembly. Casting is an ideal here because it allows complex shapes, low wedge, and good heat dissipation. The connecting lot follows a combination of rolling and forging process. The material is 4340 steel, known for high strength and toughness. It begins with hot rolling to form a bar, which is then cut into slug lengths. These slugs undergo hot cross-die forging, followed by trimming and coining to achieve the final shapes. Post-forging heat treatments, normalizing, quenching, and tempering improve the microstructure and mechanical properties. Finally, CNC machining and non-destructive testing ensure precise and integrity. Forging gives the lot excellent grain force and fatigue resistance. Next, for the wishpin, the wishpin is made from low carbon alloy cells such as X620. The main process is cold wire drawing, which produces precise diameters and a smooth surface finish. After drawing, the material is cut and chamfered, then cast hardened for surface wear resistance while keeping a taut core. The final operations are centered guiding and lapping, ensuring perfect roundness and finish. The wishpin is then extracted and held for assembly. This process ensures strength, hardness, and dimension accuracy. So, final assembly. The final step is mechanical assembly, where all components are combined. It starts with installing the piston rings, followed by connecting the piston and connecting rod using the wishpin. The assembled unit is then attached to the crankshaft during engine assembly. Mechanical assembly is chosen because it provides secure, repeatable connections and allows easy disassembly for maintenance. Maintenance. Flowchart. The first one, raw material procurement. We start by sourcing raw material like aluminum, steel billet, that base metal reshape into our final engine parts. Casting, the metal is melted and poured into mold, then cooled from basic shape of component. Like the piston, this is space forming complex shape quickly. Casting inspection, we check if the casting is defect-free. If there are problems like crack or air bubbles, the part is scrapped or removed and recast. Forging, if the casting is fine, we heat it and press it. Forging die. This set improve the part strength by refining the metal's internal grain structure. Dimensional tolerance check. We now check if the forged part meets size and shape requirement. If not, either defork or reject. Rolling, next the part go through rolling to reach the correct thickness and strength. This step also improves the material's properties. While drawing, the wrist pin is made by pulling steel through a die get the exact size. It's a precise shaping process for a cylinder strong part. Mechanical assembly. Three key steps happen here. First, fit the wrist pin into the piston, attach the connect rod to the wrist pin, and check all the alignment and clearances to ensure proper fit. Final inspection, we check the fully assembly. If it meets our tolerances, the piston assembly is ready for engine installation. If not, it's either rework or scrap. Finished product, if everything check out, we have a complete and ready to use piston assembly.
For the cost analysis, material cost moderate. Aluminum is less expensive than steel, but it have a high strength forging steel and case hardening steel at cost. Touring cost is very high. Die for casting, piston, and forging connecting rod are extremely expensive to design and manufacture. The process cost is high. Hot forging and casting are very energy intensive. Multi-step machining and grinding are the time consuming. This plan has a very high initial investment but is extremely cost effective for the high volume automotive production. Millions of parts where the tooling cost is spread out. The sustainability part, the first one, material excellence. Both aluminum and steel are two of the most recycled materials on earth. Scrap from the machining and end-of-life product can be 100% remelt. The second one, processes. High impact casting and forging require immense heat, consuming large amount of the energy, typically natural gas or electricity. The last one, product use, the positive impact. The choice of the lightweight aluminum for the piston improve the engine is fuel efficiency and reduce emission over the vehicle is an entire lifespan. This is a key of the sustainability advantage. The advantage of this plan optimizes performance. Each part is a manufacturing process is perfectly matches to its function. Casting for shape or heat transfer and forging for strength, high strength and reliability. The forged rod and hardened pin are extremely durable. High volume processes are ideal for the mass production. Lightweight cast aluminum piston is ideal for the engine efficiency. The next part is the disadvantage of this plan. The high initial cost. Tooling is the biggest financial hurdle. The process complexity. This is a multi-stage, complex supply chain to manage. The machining, heat treatment, or the separate step. The energy intensive. High energy consumption for the forming processes. In the conclusion part, we have successfully outlined a complete manufacturing plan for an automotive piston assembly. The selection of casting, piston, forging, connecting rod, and drawing wrist pin stop leverage the best process for each component's specific need. The material choice, aluminum alloy and forged steel, provided a necessary balance of lightweight, heat management, and extreme fatigue strength. While the initial tooling investment is high, this plan is the industry standard for producing a reliable, high performance, and cost-effective component for mass-produced engine.